All right, ladies, in this video, we're going to go through 5B, factorising expressions. So make sure you copy the theory into your bound reference. So the key ideas taken straight from your textbook, you can copy them down or print them and stick in your book, but please make sure they're in there. So let's quickly go through the key ideas. So 5B is just looking at factorising. So factorising just means we're taking out common factors. So for the example here, we've got negative 5x minus 20. Now the common factor there is negative 5. So negative 5 goes into both terms. And for the next one, common factor is 4x because we have 4x in both terms. Okay, so you can see it's factorized by taking 4x out. Factorizing using the difference of perfect squares, which we call dots. Okay, so a squared minus b squared equals a plus b, a minus b. So you'll remember that from previous section, 5a. So factorizing is basically the opposite of expanding. And we can also use surds. So we don't have a perfect square. So remember your perfect square, and they've listed the first three here, 1, 4, 9, then you got 16, 25, so on. Okay, well, you can just do the same thing, but you just turn it into a surd. So x squared minus 5, because 5 isn't a perfect square, you just turn it into a surd. So root 5 and root 5. Okay, knowing that root 5 squared is equal to 5, which is, yeah, it might make more sense once we start doing some questions. All right, and the other way to factorize is by grouping. So this is where you have to basically group the first two terms and the second two terms, and then you group them to factorize. And again, it makes more sense when you do examples. So let's get stuck into some of them. All right, I'm going to write 5b here just because I want to save my, oops, I'm doing a B like my son. Save these notes for people to look at. All right, so we'll just scroll up so we can actually see the questions. All right, question 3. The first one is 5 times x minus 1 minus a x minus 1. So the common factor in both this and this is x minus 1. So see how x minus 1 and x minus 1 is in both? So we're going to take x minus 1 out as a common factor, and then we're left with 5 minus a. Okay, so when we expand that, we would get the same thing, basically. So we're just factorizing, trying to find the right word. All right, now let's look at question B. So I'll just change to my red pen to write it down. Oh, excuse me, that was supposed to be red. Of course, you want to pop up. Okay, so let's write B again. Where are we? B, x plus 2, sorry about that, x, and 3x plus 2. Okay, so again, we're looking, excuse me, I just want the black. Looking at each term. Okay, and you can see there's x plus 2 is a common factor, so we can take that out. And then we're left with b plus 3. Now, you can have them around the other way, so just remember, because there's like an imaginary multiplier sign in there, it doesn't matter if you wrote it the other way. You're probably not going to, because usually when we factorize, we tend to write the factor first, the common factor. All right, and let's quickly do C. So we've got a, x plus 5, and you can see what the common factor is. It's x plus 5. But when we get to the harder ones, you'll see that it's not going to be so straightforward. You'd actually have to factorize by grouping. So we've got x plus 5, and then we're left with a minus 4. Okay, question 4. I'll go on another page. Okay, so now we're going to be factorizing using the difference of perfect squares. So we've got x minus 9 Now, if we just scroll up to our, whoops, you can just see here. All right, so we're factorising using the difference of perfect squares. So a squared minus b squared. Now, when I start teaching this, I say, all right, let's identify what a is and what b is. So a is whatever is on the left term. So you can see here a and then a. So in this case, a is going to be x. And what is b? Now, remember, this is b squared. So b is going to equal to 3. Okay, so b squared is 9. That means b is going to be 3. So in my, when I'm factorising, now I just need to write a plus b, a minus b. So it's going to be x minus 3. Oh, sorry, x plus 3, x minus 3. And if I was to expand that, so if you ever want to just check whether it's right, you can just expand. So x times x is x squared. X times negative 3, or is that negative 3x? And then plus 3x, and then minus 9. So you can see there, these two cancel out, and we're just left with x minus 9. Okay, so you need to identify your a and b and use the difference of perfect squares formula. All right, let's move on to b, which I can still see on the screen, so that's good. I don't need to get rid of those key ideas. So b is x squared minus 25. Okay, so identifying a first. So a is x, and b is the square, well, a is the square root of x squared, and b is the square root of 25, which is 5. So your expression is just going to be x minus 5, or x plus 5, sorry, x minus 5. It didn't matter if you wrote minus first. Okay, moving on to, now it's not c, it's e. 4x squared minus 9. Okay, so remember, a is the square root of this first term. So we take the square root of the 4 and the x squared. So the square root of 4 is 2, and the square root of x squared is x. And then b is the square root of the second term, which is going to be 3. So when we're factorising, we're going to have 2x plus 3, and then 2x minus 3. All right, scroll, scroll, scroll. Now, f is quite similar in that we've got a coefficient of a squared, but it's the same thing. Identifying a, which is the square root of this first term, so the square root of 36 is 6, square root of a squared is a, and then b is going to be the square root of 25, which is 5. I just noticed that we've got two a's, so the question itself had an a, and we use a in our formula. Usually we wouldn't let a equal two different things, so just be aware if you do that, that the a's are different a's, if that makes sense. Okay, but we're just not really assigning them any values at the moment, we're just factorising. Okay, so we're going to have 6a plus 5, 6a minus 5. Okay, moving on to question 5. So for question 5, what we need to do first is take out a common factor. So we've got 2x squared minus 32. So in the previous ones, you couldn't take out a common factor, but here we can. So I can see that 2 goes into 2x squared and 32. So I'm going to take 2 out as a common factor. So that means my answer is also going to have a 2. So if you just set up your brackets, it's going to look like that. You just need to identify what your a and your b is. So a is the square root of x squared, which is just x, and b is the square, oops. That should be a 16. Sorry about that. Okay, so that's because 2 was taken out as a common factor, and I didn't fix that. always making small mistakes, but I knew it had to be a perfect square. That's how I knew it was wrong. Okay, so we're going to have x plus 16, x minus 16. No. Oh my gosh, what am I doing? Oh, so I get distracted. It's not 16. Oh. Can I just leave you on there, please? All right, let me just write over it. Actually, I've got to get rid of this. Oh. If you're wondering what I'm doing, it's the square root of 16, so b should be 4. So that means that should be 4, and that should be 4. Because I was looking at it and I was like, oh, that's not going to give me the right answer. And then I realized exactly what I did wrong. So I apologize. Hopefully you noticed as I went. All right, I don't think I'm going to fit B in there, so I'm going to scroll down to the next one. Okay, so 5B. Also remember, girls, when I create these videos, I've usually created quite a few before. I mean, there's always one that's going to be there from the beginning for the first one. But yeah, this is only the second one I've done, but I've been talking to the screen now for over 30 minutes, so it can get quite tiring. Okay, so I've taken 5 out as a common factor, so I'm just going to rewrite my answer with 5 out the front and just identify the A and the B. So the A is the square root of x squared, which is x, and B is the square root of 9, which is 3. So we've got x plus 3, x minus 3. Okay, and I kind of feel like we don't have to keep doing some more examples. So I might just move on to question 6 because I don't want these videos getting too long. And 6 is a good one because we're going to be dealing with surds. So remember when we did our key ideas, so I might go back up. Okay, so you know, in the previous example, we could easily make the answer an integer, but this 7, the square root of 7 is a surd. So we can still apply the same thing, identify your A and your B. So A is going to be the square root of x squared, which is just x, and B is going to be the square root of 7, which doesn't simplify to a whole number. So we're just going to leave it as the square root of 7. So when you write your factorized expression, you're going to have x plus root 7, x minus root 7. So it's pretty much the same as what we did in question 4. We're just not dealing with perfect squares anymore. Okay, so we can just leave them as surds. So let's look at question 6B. We've got x squared minus 5. So the same thing, identify your A and your B. So A is the square root of x squared, which is just x, and B is the square root of 5, which is just a surd. And then we write our expression. So it's going to be x plus root 5, x minus root 5. And it's the same thing for D and E. So I'm not going to do them either because they're pretty much the same thing. Moving on to last question, question 8. Okay, so we've got x squared minus 2 on 9. All right, so we can identify our A and our B. Okay, so A is the square root of x squared, which is just x, and B is the square root of 2 on 9. Now, remembering your surds, okay, so can we take the square root of 2? No, but we can take the square root of 9, so it's just going to be 3. Okay, so B is equal to root 2 on 3. So when we factorize, we're going to have x plus root 2 on 3, and then x minus root 2 on 3. All right, and then question B. x squared minus 3 on 4. So the same thing, identifying your a, which is the square root of x squared, which is just x, and b is the square root of 3 on 4. Now you could do that in one go. We can't simplify root 3, but the square root of 4 is 2. So when we're writing our factorized expression, we're going to have x plus root 3 on 2, x minus root 3 on 2. All right, and then the next two, okay, might look a little bit harder. So let's have a look at, what is it, e? Let's get my mouse working. Come on. Okay, e, we've got x minus 2 squared minus 20. All right, so this is still the difference of perfect squares. A still comes from this whole expression. So if we were to take the square root of this, okay, we would get x minus 2. And then we've got the square root of 20. Now the square root of 20 you can simplify, okay, so we've just done surds, so I'm going to just write the simplified version there, 2 root 5. So your expression is going to be a, which is x minus 2, plus b, which is 2 root 5. And then we've got x, oh, I always write minus. Oh no, I did, sorry. I'm all good. Minus 2 root 5. Okay, so we've got, I might just write that here. This is our a plus our b, and this is our a minus our b. Okay, so exactly the same thing. We've just got 2 terms here, whereas before we only had 1. All right, and then question F is quite similar. We'll just quickly do that one. So we've got x plus 4 squared minus 27. And when we do quadratics, this will probably make more sense why we're doing this. Because you might be thinking, why? Why would we do this? Yeah, so after, probably not immediately after quadratics, but soon after quadratics, we'll be doing parabolas, which is the graph of a quadratic. All right, let's just simplify square root of 27. So that's going to be 3 root 3. So our expression is x plus 4 plus 3 root 3, and then x plus 4 minus 3 root 3. And obviously you can't add them because they're not like surds. Okay, you've got an integer and you've got a surd, so you've just got to leave it like that. All right, bye.